The world around us is a bottomless source of inspiration. Over billions of years, countless patterns, systems and mechanisms have accumulated in nature. The science of how to combine the ideas of the best of them with modern technologies is called bionics.
The task of bionics is to model the structures and behavior of biological systems, namely the construction of artificial systems that reproduce the activity of individual organs, their internal and external interactions.
The connection of robotics with bionics can be traced back to the 18th century, since the creation of copper mechanical ducts by Jacques de Vaucanson. Nowadays, bionics mainly helps modern robots move more naturally and interact better with the world around them. As a result, many machines, striking in their similarity to living organisms, have appeared in our world. The necessity for robots to adapt to changing environmental conditions required them to develop sensory organs similar to human ones: hearing, vision, touch. So, sensory systems can be improved with the help of bionics. The vibrissae tactile hairs came from nature. The principles of their operation were used to develop a sensor that is able to determine the position of an object and form a two-dimensional image.
Speaking of the ways of moving robots, in addition to moving on a smooth surface, it should be mentioned such ways as jumping, crawling, swinging, swimming, flying and moving along walls.
For example, the Limolinde excursion mechanical utility robot is equipped with special Velcro straps that allow it to hold on surfaces made of various materials and easily move along walls and ceilings. A similar way of movement was borrowed from geckos and spiders.
Another important point in robotics is the ability to grab objects. And here bionics also played a role. Not so long ago, a new robot grip was introduced, which was based on the structure of the chameleon tongue. FlexPeg gripper can lift and hold objects without additional wasting of energy. In addition, the grip can be arranged much more simply than a mechanical hand consisting of great number of elements. The robot classification currently consists of 3 items and includes modular, swarm and soft robots. Modular robots include the salamander robot, Pleurobo, which uses technology to connect the spinal cord and brain, which may be used for neuroprosthetics in the future, and Bionicopter, a miniature dragonfly drone. An excellent example of swarming robots is RoboBee, which can fly, swim, and dive. Soft robots can be safely called the most amazing group. There are no hard materials in them. They are printed from soft silicone and work by chemical reactions. Such robots can be used for rescue on the water or for strategic purposes because they easily penetrate into bottlenecks, taking the form of the surrounding space.
There's also a group of social robots that are used as pets that do not need care. They really look like living organisms in their habits and appearance. These are the robots Silparo, Spotmini, a 4-legged robotic assistant resembling a dog, and Miro.
It is safe to say that in the coming years, bionics will bring a lot of amazing possibilities to robotics. For example, artificial muscles are currently being developed that will replace the usual electric motors in robots. It may seem that nature offers us the most optimal solutions, but this is not always the case. So, only the best of these solutions that have emerged over the centuries of evolution are selected. Of course, the application of bionics requires a deep understanding of nature. It is a combination of biology, physics, chemistry, and engineering. When all these elements come together, the results can be simply amazing.